Okay, yesterday we did some more programs. I'm not even going to spend that much time recalling them. We're working with dictionaries. To add another item to a dictionary or pair, key value pair, you're going to say dictionary name, and then within like a basically index notation with the brackets, the new key, and then gets new value. So that's all I'm going to do for recalls. Right now, I'm going to jump back in. This stuff's due tonight. I'll be back in a bit to recall what I did. Alright, guys, so. Okay, I finished up a program. It was on using tuples. It was a tuple program. So, interestingly, tuples are immutable, but you can recreate a new tuple by assigning. You can actually like essentially append a tuple by rewriting the tuple. So it's not the same tuple, it's a new tuple, but it can have the same name. So if you have a tuple and you want to add something to a tuple, you say that tuple name gets, so you're reassigning current value of the tuple plus parentheses the value you want, and I think comma space. That's what we did there. I don't know if that's necessary or you have to do that, but maybe. But yeah, that's how you do that. So that was interesting. We had to basically take an input of numbers and then output it in reverse order without using the reverse or reversed function. And so I used a for loop with using range with the length of the tuple minus 1, and then used indexing, backwards indexing to that. Well, yeah, I used the range first. The x for range value or function is or was length of tuple minus 1, comma, so the y value was -1, and then the z value is -1. So that iterated down. And I created a while loop first, and I'm like, this is counter controlled. I should use for loop. I need to get more comfortable using for loops. I have been using while loops for everything. So every time it's a counter controlled, I try to use for loop now. Anyway, so we don't have lecture or lab today. The lab was canceled for fall break essentially. And so I've got my first exam. I think you can start taking it today, or the second quiz. So I believe it's open note. That's something I can actually check. Or open textbook at least, which I didn't use last time, and I missed a few questions. So I still have that first quiz to go over and review what I missed. Yeah, the quiz is now available. You'll have 90 minutes to complete the quiz, make sure questions. You will see one question at a time and be able to backtrack. You need to install Respondus. I don't know if we can use the textbook. We were last time. Let me parse this text and find quiz 1 announcement. All right, he didn't say anything about the textbook, I don't believe. So I'm sure we're probably gonna use it again. So that will have then I can actually use like a freaking, not an IDE, but like a web-based IDE, like programming window with a console terminal. Okay, anyway. I wanted to try out, I'm not a huge fan of studying, because I've already spent so much time recalling, retrieving, practicing. So, but I want to give it a try. Maybe just for 25 minutes, or let's see what we can do. The professor gave a really good potential use for quizzing or studying, where we have a textbook that's very well structured. So what I can just do is say with ChatGPT, hey, I'm a CS1 student and I'm preparing for a quiz. Can you, the topics cover, and then we'll say, so let me make sure I get the right kind of quizzes. Not much information there. Okay, here we go. Lectures 7 through 12. So lecture 7 is selection with if statements. I don't even know. I could even put the subsections in there. Selection with if statements. So I'm going over time. I'm going to add this to my time though for later. Selection with if statements. This is also why I practice typing so much, because it's so useful in the age of AI right now. To be able to quiz yourself, it's like, if I can type twice as fast, I can go through twice as much quizzing. All right, I'm looking at the wrong thing. Here we go. Selection with if statement. Detecting ranges with branches. That's 8. Selection with logical operators. 9. I can't see this one. It doesn't fully show us always the whole title. Comparing data types. Precedence, there we go. That's pretty great use. Okay, now lecture 11, introduction to loops. All right, here we go. More about loops and an intro to lists. That's what we're going over. And then I can even put the subsections, why not? Let's see what happens. Just be more granular. Copy. It's also a good look at how long it takes to set this stuff up, just for my own reference later on, to know how much time it takes to basically study. What I'm doing right now is I'm going into each subsection of the chapters and I'm just placing them under the associated lecture / chapter, just so ChatGPT stays as focused as possible on what we covered. Here we go. It actually wouldn't be a bad thing not include the subsections, just for the sake of getting more of a general understanding of the topics, like another angle that maybe we didn't cover specifically, but already so far into this that I might as well. That I might as well take care of the rest. Here we go. Counting, list basics, binary numbers. Here we go. Counting list numbers, list basics, more while loop examples, while loops, loops general, conditional expressions, order of evaluation, comparing data types and common errors, detecting multiple features with branches, detecting ranges with branches, detecting ranges using logical operators, detecting ranges with branches. Detecting ranges with branches general. Detecting equal values with branches. If else branches. All right. I have about 30 to 60 minutes to get the most out of this. I think we should do high level stuff first to identify potential weaknesses and focus on weaknesses. If a big picture is good, move to the next topic after one question. Once all of the big picture is at general competency, move to a more granular look, pass over looking for weaknesses. We should continue like this, interleaving and never spending more than a question on a single topic. That's a really smart, high yield approach. Let's treat this like an adaptive mini exam. Here's how we'll structure it. Phase 1, big picture pass, 1 conceptual or code reading question per topic, about 10 questions total. You answer quickly, gut feeling, I'll mark it yes, or solid, or needs more depth. Phase 2, focused interleaving, we zoom in on topics with mixed conceptual plus code trace. Phase 3, short edge case or reason drilling to bulletproof your understanding. Ready? Here's phase 1, big picture concept per area. 1 question at a time though. All right, we'll just do like 1 question for now. What is printed? So x gets 10 if x is greater than 5. Print A. Print B. Infinite loop. Oh, facts. I had loop in my mind. So all right. Question 2, if else branches general, What's the key rule about mutual exclusivity between if and else blocks? What's the key rule? Either if block will be executed or the else block will be executed. Not both. Never both. Never neither. Exactly right. That's the core principle. Mutual exclusivity. Only one executes either the if block if the condition is true or the else block if the body if false. You always get exactly one outcome. Never both and never skip both. You clearly have a strong grasp on basic branching logic. Question 3. Branching equal values with branches, or detecting equal values with branches. What's wrong, if anything, with this code? If x gets 5, you are assigning x to 5 when you mean to check equality. This will output an error in Python, and then what you need to do is replace equals with double equals. Wow, thinking. Okay, spot on. In Python, equals is assignment, double equals is equality. Using gets in an if condition is a syntax error. Question 4, detecting ranges general. How would you check if score is between 90 or 70 and 90 inclusive? Write one Python if line. One line. If score is greater than or equal to 70, we can actually just say 70 is less than or equal to score, which is less than or equal to 90. That's the most concise and Pythonic way to express a range check. Python supports chain comparisons. Could have used the and as well, which I was going to do originally, but I said, well, let's make it more concise. Question 5, selection with logical operators. What's the difference between these two conditions? If, exactly what I just wrote, and if score is greater than 70 or equal to 70, or score is less than or equal to 90. The first is a and operator, which means both conditions need to be true for the statement to be true. The second is an or operator, which means that only one has to be true for the whole statement to be true. In the case of this example, any numerical value of score will be true. The second statement. Excellent, exactly right and beautifully reasoned. That behaves like and. Both sides must be true, only true for values between 70 and 90 inclusive, or almost always true because every number is either greater than 70 or less than 90. So the condition is true for all numbers. You're clearly fluent in logical operators and range detection. Okay, one more question. Detecting ranges and gaps. Write a condition that prints outside if n is not between 10 and 20. Write a condition. If n if n if what if we say n is greater than 10, or say 10 n 20, so 10 less than n less than 20. So if that's gonna be true, then we print. We could use an else statement, but we could say if true does not equal, and put parentheses around it. If it is true, I guess 1, 2, 3, 4 print outside. I guess we could also do if n is less than or equal to 10, or put a parentheses around them, or n is greater than or equal to 20. One, two, three, four, print outside. All right, it's gonna be the last one. Beautifully done. Both versions are logically valid, but your second one is the clean, conventional approach. The first works too, since you're inverting the truth, but the second is clearer and easier to read from most code bases. You're rock solid on logic and condition design. Okay, that's gonna be it for now. I'm gonna be back to do more quizzing on ChatGPT later today, so talk to you then. See ya. Alrighty, I am back for computer science. Yep, let's continue doing this ChatGPT quiz. All right, question 7. Comparing data types and precedence. What happens here? False is printed because the string 5 equals numeric 5, which are not equal, so it's false. Python doesn't perform automatic type conversion for equality checks between strings and numbers. False, because one is a string and one is an integer. You've clearly got type comparison down. Order of evaluation, question 8. What happens here, or what's printed here? X gets 2 if x is greater than 1, true, and x is less than 10, true, or x is equal to 0. Okay, precedence here. Or is the last thing that's checked, and is the second last thing checked. Equality, that's something I need to review. Here we go. Precedence. I remember pen M DOS, parentheses, exponentiation, negation, meaning not, pen, negation, multiplication and division, addition and subtraction. Okay, and then we go into what? We got logical operators, equality operators. Then comparison operators. Equalities and not equals to, greater than equal to, less than equal to. Those are comparison operators. Okay, so it goes PEMDAS, then I believe it goes equality operators. Damn it. Equality operators. No, I think it's comparison operators, then equality operators, then logical operators, but it's logical operators are and then or, but what's the other? There's another logical operator. Yeah, this is important to know. All right, my final guess is, so the PEMDAS, then it goes comparison, CEL, kel, PEMDAS, kel, and the logical operators and an or. Is it not? Goes not. I thought negation. Oh my gosh, I don't know. Not, then, and then or. Anyway, this is gonna say true and true. That's true, yes. Actually, no. Fuck, what comes first, and or? I don't remember. Or, I thought or was last, so I'm gonna say yes. And has higher precedence than or, boom. Okay, before we move on, it's PEMDAS. Negation's like multiplication, surely. PEMDAS, then comparison, then equality, then logical, not logical, and logical or. That's almost perfectly right. Here's the exact Python operator precedence. Order relevant to what you've learned, simplified at your level. Parentheses, arithmetic, comparison, equality, logical, not. Wow, I got it right. Okay, I got that nice. But functions come even before, have the highest precedence. Is it a function? Yeah, functions. Okay. So yes, functions calls come after parentheses for groupings in terms of how you write them, but in the evaluation hierarchy, they're exactly first, right after the object slash Attribute resolution. What the fuck does that mean? I don't really know. I think I might. Okay, whatever. Okay. What is printed? X gets 0 while x is less than 3. Print x and then increment by 1. 0, 1, 2. Okay. That's right. Let's just go to the next. All right, explanation. Starts with x gets 0, loop runs while x is less than 3. Each iteration prints x, then increments by 1. When x becomes 3, the condition fails, loop stops. You've clearly got loop flow nailed. Lists and counting. Question 10, what is the output? Nums, list equals, nums is a list 1, 3, 5, count equals 0, or get 0 for n in nums. Count plus equals n, print count. So it's gonna be 1 plus 3 plus 5, 9. The loop iterates, that's correct. The loop iterates through 1, 3, 5, summing them. Then prints count. You officially passed the big picture phase with near perfect accuracy. Only the first indentation trap got you. Let's move to phase 2, interleave deep dive. We'll mix in weak spots and tricky edge cases, indentation logic, while loops, lists. Each question will target applied reasoning rather than simple recall. Ready for the first interleave challenge? Yes. Okay. What is printed? X gets 5. If x is greater than 2, that's true. If x is less than 10, that's true. Print A. And then it says print C. So A and C. Correct. Let's just keep going. You handled nested conditions and indentations perfectly. Interleave challenge 2, logical operator traps. What's printed? X gets 4. If x is greater than 10, false. Or x is less than 5, true. And x is not equal to 3, true. So overall it's gonna be false or true, which is true, so yes. All right. You've clearly mastered logical operator precedence. While loop logic, what's printed here? X gets 3 while x is greater than 0. Increment down x1 and then print x, and then when done, print done. So while 3 is greater than 0, decrement x, so now it's 2, print 2. Decrement x again down to 1. X is not greater than 0, so done. What? Oh, facts. Yep. So it should have been 2 minus 1, 3, x is 3, minus 1 is 2, print 2. Then it's while 2, that's true, minus 1, use 1, then 1 is less or is greater than 0, so decrement by 1. True, got that. All right. Got it. Interleave challenge for counting logic. What's printed? we got a list of nums, count equals 0 for n and nums. If n modulus 4 equals 0, then count plus 1. So only it's going to be 2 of them, because it's 4 and 8. Okay. You've clearly got loops plus conditionals integrated well. Interleaved challenge 5, lists and conditions together. What's printed? Nums 1, 5, 10, 15, total 0. For n and nums, if n is less than 10, total plus equals, or it's going to get total plus n. So 1 is less than 10, so 1, then 5 is less than 10, so 6. 10 is not less than 10, 15 is not less than 10, so 6. All right, output is 6, good. Not missing a beat on control flow or condition filtering. Okay. Control flow is basically like while loops, for loops, if and else. This is controlling the flow, I think. Condition filtering. Okay, I think that's conditions. Okay. Binary numbers and loops. What does this print? N gets 5 while n is greater than 0. True. Print n modulus 2. Then floor divide n by 2, and that's what n now is. So 5 modulus 2 is going to be 1. 2.5 floor divide, or so 2, 0. 2 floor divide by 1, or 2 is 1. 1 is greater than 0, so 1. 1 floor divided by 2 is 0. Okay. You've officially solid across all core concepts. That's it. We got a few more minutes. Let's do this. Would you like one final mini quiz? 5 questions combining everything, timed in rapid fire style. Well, give me a grade on all of the concepts that will be on the exam. 16 questions. Why? That's really quick. Selection with the if statement, A+. If else branches, A+. Detecting equal values, A+. Detecting ranges, general with logical operators, A+. Detecting ranges with gaps and negations, A+. Comparing data types and precedence, A+. Order evaluation, A+. Conditional expressions, A. Conditional expressions, A, implied. Though not directly tested yet, your understanding of ternary-like conditions, if A, condition else B, is likely strong given your logic fluency. Quick review of syntax before quiz, just ensure muscle memory. Loops, A. Great understanding of while loops and iteration flow. One small off by one slip, very minor and now corrected. Suggested practicing mentally tracing 1 or 2 loops to ensure perfect termination logic. List and counting, A+. Binary numbers, A+. All right, well, okay, well, let's hit the things that were A and not A+. Why did it not test me on that shit? What does this print? X gets 0 while x is, or 0 is less than 3. True. X gets incremented by 1, print 1. Okay. 1 is less than 3, increase by 2. Or increase by 1, print 1. Or 2. 2 is less than 3, so increase by 1, 3, print 3. 3 is not less than 3. Boom. All right, exactly correct. Conditional expressions, aka ternary operators. What is printed? X gets 10, print high if X is greater than 15, else low. That's a ternary operator. You've got conditional expressions fully mastered now. Operator precedence. Function calls versus grouping. Quick check. What's printed? Define f of x. Oh, we've never done define. Return x plus 1. Okay, that must be a function. That must be how you define a function. Define f of x. Return x plus 1. Print f2 times 3 plus 1. I think function rels first. f2, so 3. 3 times 3, 9, 10. I would say C. All right, good. That is how you define a function. Okay. All right, let's get a challenge question. So they're going to combine a bunch of stuff here. Write code that starts with a list of integers from 1 to 15. Use a while loop for no for loop allowed to remove every number not divisible by 3 or 5. For each remaining number, prints its binary expression or representation if it is less than 10, otherwise print big. Counts, holy shit, counts how many times big was printed and prints the count at the end. Holy shit. All right, this is quite the challenge. I'm gonna open an IDE and then I'm gonna do it in there and not in ChatGPT so I don't accidentally hit enter. All right, so we need to start with a list. 15 integers from 1 to 15. All right, int underscore list gets a list of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's just do that. What is line? What is that called? Line. There's a term for it. Wrapping. 14, 15. Let's get this one down there. All right. There's the list. Now we need to use a while loop to remove every number not divisible by 3 or 5. Okay, while, well then we'll say there's an increment I equals 0 while I is less than length of int list minus 1. If int underscore list at index I modulus 3 is equal to 0. Then say, I think it's int underscore list dot pop at I, potentially. We can just check that. Print int list. That didn't work. Oh, because we didn't reassign it. Wait, what? No, the pop should still work. Debug. I meant to say less than rather than greater than. It still doesn't work. Here we go. What the hell? It still didn't update? I clicked the wrong again. Boom. Less than. There we go. And now nothing runs. Okay, at least that's right this time. True. False. Okay, that's why I didn't increment I. Okay, there we go. Still nothing. Gotta love it. Man. Wouldn't have done well if I tried to do this without the IDE. Constantly debugging. Why did it not increment? Oh my gosh, because I put it in there in the code block. Get out of there. Okay, there we go. It is pop, and it did work. All right, after that whole thing, now elif int underscore list at I is, or modulus 5 is equal to 0. Then we can say int underscore list dot pop at I. All right, that's gonna remove all the 5s and the 3s. No, it didn't. Why is 15 still there? That's because I used less than and -1, so I need to get rid of that -1. Okay, let's continue. Remove every number not divisible. Okay. Not divisible by 3 or 5. There, well, critical error there, I'm missing that. Luckily, what I can do is salvage a little bit of this, get rid of the LF, and then copy this, cut that up here. No. Okay, there we go. Bang. Then we say, instead of equals 0, we say doesn't equal 0. And then we say if int list at index I modulus 3 does not equal 0, or int list at index I modulus 5 does not equal 0. colon int list pop I bang. What the hell is this? Now it's not working here. How are we getting... Two should not be a number we get. If int list at modulus 3 does not equal 0, true. That's true for 2. Or modulus 5. No, it needs to be and. Boom. Still, we're getting 2. Debug. One modulus 3 does not equal 0, true. Therefore, we're going to get rid of 1. Increment I. 2. What the hell? What? I hate how we don't have a backwards on here. Why is that a 3? That's not right. This is a bug in Donnie. What the hell, man? Why did that return a 3? I plus equals 1. I is now 1. If int list why is that returning 3? There's no reason that should be returning 3. Oh! Because we popped it. Okay. So the problem is we're removing something. What we should do, I guess, is start at the length of int list and then decrement by 1. I think that should work. No, of course it doesn't fucking work. Dude, I swear this stuff. Okay, yep. Int list minus 1. Okay, this is such a simple program, man. I don't know how this has gone so awry. There we go. Are you serious? What? How is it out of range now, dude? 15 minus 14. 15 minus 1. 14? There we go. Minus 1. 13. Looks good to me so far. Looks great so far. What happens? Oh, it must go to negative number. No, now we need to say if I is greater than 0. Nope. Greater than -1. Boom. There we have it. 3, 5, 6, 9, 10, 12, 15. Oh my gosh. Okay, we've started with a list, okay. For each remaining number, print its binary representation if it's less than 10. Okay. Now we need to say if we're just going to create another list. I mean, while loop, I mean. While I is greater than -1. If int underscore list at index I is less than 10, then we need to print out the binary. Binary representation. Oh my gosh. Okay, it's something along the lines of 2s. You gotta divide by 2. Let's just say, for example, let's create a little binary thing over here. If you have the number 10, you need to modulus 2 that's what you need to store, right? Modulus 2, and then you floor divide, and then you repeat. So first will be 0, then it would be 1. Okay, hold on. It's gonna go from 10 to 5 to 2 to 1 to 0, right? So this is gonna be 0, 1, 0, 1, 0. That's not a good example. We need 11. 11 would be, let me just type this out. What is 11 gonna be so we know what we're looking for? 11 in binary. You can have a 1 at the end, 2 and an 8. So 2, so 1, 0, 1, 1. That's 11. So 11's gonna go to 11 to 5 to, really, 11 to 5 to 2 to 1 to 0. That ain't right, dude. Oh, 0. What the hell, dude? What is 11 in binary? I got that right. Now how do you get there? 11 modulus 2, 1. Floor divide by 2. 4 divided by 2, 5.5, so 5, 1. 2.5, 0, 1, 0. Okay, this gives you the backwards. Modulus 2, 4 divided by 2 gives you backwards binary. So what we need to do is create like a list. This is crazy, bro. This question they were asking me to this is such a massive difference. The questions took like 1 minute or like 10 seconds. All right. We need to create like a variable. Backwards underscore binary. And that's going to get 0. No, it's going to get an empty string. I think it allows automatic conversion. About to find out though. Then you need to take int underscore list at I. I don't want to change it though. Get base 10. And then we're going to say base 10 modulus 2. Now we're going to store that backwards binary plus equals base 10 to modulus 2. And then you're going to say base 10 floor divide by floor divide by 2. We're going to have to create like a nested loop in here so this doesn't get reset every time. So we create the backwards binary string, empty string, and then we need to say while. And we also need to store an int list here. And then we need to say while base 10 doesn't equal 0. Is it going to be doesn't equal 0? Or greater than 0? We're going to find out. Right. Then what we need to do is keep doing that. And then after that's done, it needs to print out, and it basically needs to print reversed, and then backwards binary. Holy shit, dude. Here we go. Let's get rid of this. Let's copy that. No. Comment that out. Comment this all out. Comment this out. Let me just say 11. Just copy this out. Comment that out. Backwards binary empty. So this backwards anyway, base 10 equals 11. Can only concatenate strings, not int string. Okay, there we go. Son of a bitch. What's going on here? There we go. You basically say base 10 gets typo. Oh my gosh. Backwards underscore binary. No, it just needs to say binary. Binary gets reversed and then backwards underscore binary. I believe that should work. I think you can reverse strings like that. Print binary. Nope. Okay, reverse strings in Python with reversed. The reversed function takes an iterable, returns an iterator that yields the element in reverse order. For a string, it yields individual characters in reverse. Quotation mark dot join iterator. Since reverse returns an iterator and not a new string, you need to join the reversed iterator back together to form a reverse string. Okay, this is crazy. Join. No. Yeah, it's dot join. Okay. Then binary. Boom. Are you fucking kidding me? Reversed. My string. Reverse string. Bro, I'm losing my shit here. This is fucking pissing me off. Alright, we basically need to define a function, but I can't define a function. We haven't learned how to do functions yet, so what I'm going to do now is create down here while length of backwards binary -1. Bro, this is ridiculous. Why the hell did they give us this kind of thing, dude? -1 is greater than -1. Binary gets nope, we need a new iterator. J gets backwards binary. No, blend -1. While J is greater than -1, binary equals no, Oh, we need to define binary. Binary equal or gets empty string. Okay, binary plus equals backwards underscore binary at J. Craziness. Backward binary empty string. Base 10 equals 11. While 11 is greater than 0, true. Backwards binary plus equals a string. Okay, good. Base 10 equals base 10 floor divided by 2. We're going to keep doing that. Eventually we get out. I need to do the debugger here. Now we have the backwards binary. Huh? 11 in binary. Okay, good. It is backwards. Then we're going to step into this. 3. Binary. Empty string. All 3 is greater than -1, true. This is working. Nope, it's not working. We forgot to iterate them. J minus equals 1. All right. There we go. That's functional. Now we need to nest it correctly. We need to do that for everyone. Are we printing this out? Print is binary representation. Okay. Can uncomment this stuff all out then. Okay. Doesn't work yet. That's because this thing still says 11 somewhere. Yep. This needs to be if int list at I int underscore list at index I. If int underscore list less than 10. I don't understand what's going on now. True, false. Infinite loop, this always happens when I use while loops. We didn't increment the while loop. I minus equals 1. Oh my gosh, did we do it? Not quite, did we? Because it goes backwards, doesn't it? It does go backwards. It needs to not go backwards. Can we do it not backwards? If we say I is 0 and I increment up, true, we can do it this time, right? Why? Because they're not going to change the list. While I is less than length of begins a list. -1. I cannot believe we've done it. Okay. Else. Print. It's just say like big in all caps. And we need to count how many times big gets big. Count how many times big was printed and print out the count at the end. Big underscore count gets 0. Big underscore count plus equals 1. And then at the end, print big underscore count. Oh my gosh, we've done it. What? No, what is one? That's 9. That should be right. I think they had it wrong. 3, 5, 6, 9, 10, 12, 15. 3, that's 5, 6, 9. It's big. 10 is too big. 15 is too big. It should be 12. This should be 15 is too big too. This is not right. There's this. Boom. Oh my gosh, I think we've done it. That took like an hour. No, it took 40 minutes. Start with a list of integers from 1 to 5. All right, here we go. Check it. Start with a list of integers from 1 through 15. Use a while loop, no for loop allowed, to remove every number not divisible by 3. Okay. This is how we do that. Removing, if it's not equal to 3 or 5, it gets removed. That's where we end up with. Remove every number not divisible by 3 or 5. For each remaining number, print its binary representation if it's less than 10. Right? Here we go. This is that. This is printing binary if it's less than 10. There's the 4 outputs that are binary, and then for each remaining number, print its binary, otherwise print big. So there's that. And then counts how many times big was printed and prints it out, prints that count at the end. There you go, 3. Oh my gosh, dude. That sucked. I mean, it was kind of alright. It was kind of fun, but I don't know why it sucked, because I was on this video the whole time. Alright, there you go. Happy ChatGPT. That's clean, fully correct solution that respects the constraints. While loops only, filtering plus binary print, counting big. It also avoids a classic skip on pop bug. Skip on pop. By iterating backwards, that's I ran into that pop a problem. Safe in-place deletion, backwards index. Solid control flow, 2 clear phases, filter, then emit, binary logic correct, LSB to MSB, build plus reverse, tiny edge case note. If a 0 never sneaks in, or ever sneaks in, your binary builder would print an empty string. You can guard with not needed here, just awareness. Efficiency improvement still while on only while loops. Your pop inside a list. Here's an in-place compaction pattern that keeps it without extra lists. Oh, yeah, okay, makes a new list. No? Whatever. No, we're done. You've got full mastery over every concept that'll be on the quiz. You're walking with an A+ command, logic loops, list, and control flow. And that last challenge proves you're thinking like a true programmer, not a memorizer. Alright, that's it. For today, I will talk to you tomorrow. We'll take the quiz tomorrow. So, talk to you then. See ya.